Okay, so ladies and gentlemen, you are welcome. So this is another series of general chemistry questions. Don't forget that we stop at question 18. And if you miss the video or the other uh, for the other questions, so I will attach it to in the discussion box of this video. And don't forget to subscribe and join the YouTube community. So here, the question 19 says, an isotope of uranium has an atomic number of 92 and a mass number of 235. What are the number of protons and neutrons in the nucleus of this atom respectively? So what we are going to do here first, let's draw the element itself. So uranium is like this, and then the mass number is 235 here, and then the atomic number is 92. So the question says that we should actually calculate the number of protons and neutrons. And how do we calculate this number of protons? So the atomic number is 92. And of course, when we said atomic number is the number of protons that are present in the nucleus of the atom, meaning that the protons number and atomic number are the same. So if you have atomic number is as 20, then the proton number is 20. So here we have the atomic number 92. So that means that the proton number is going to be 92. So we have 92 as the number of proton. And of course, more importantly, if you have an element that is electrically neutral, that is the element that doesn't have positive or negative charge attached to it. So the protons number and electrons number are always equal. But if the number of, if there is charge, if the proton or if the element having a positive charge, it means that the number of electrons usually decrease by 2. Like, let me just give this example. Let's say we have sodium plus, and we have atomic number 11. So the proton number doesn't change, so it's 11. And then because here it is positive charge, sodium is plus. So if you are to get the electron number, it means that the number of electrons is decreased by 1. So therefore, instead of 11 is now going to be 10. So when you have an element that is electrically neutral, the protons and electrons are equal. But if the elements, they are not electrically neutral, like for example, in the case of sodium here, it is positive charge, so that is why the electron number decreased by 1. If it is plus 2, then it will decrease by 2. So let's look at chlorine. So chlorine has atomic number of course, 17. So in this case, it has negative charge. So the proton number, as I said, doesn't change. So it's 17. And then the electron number, because it means that chlorine here gain minus 1 electron. So it means it gain or it accepts 1 electron from metal. So therefore, the electron number here is going to be 18. It's going to be 18. So then, of course, here we have the mass number as 235, and then the protons number is 92. So to calculate the neutrons number, you have to use a formula which says mass number is equal to proton plus neutron. So the mass number is 235. The mass number is 235. And then the proton number is equal to 12. So it is given as 12 then plus n. So therefore, to calculate, and so the here is 92. So the protons number is 92 then plus neutron. So therefore, the neutron is now going to be, we are now going to make n subject of the formula. So we have 235 minus 92, and that will give us the neutron number. So we're now going to say 235 minus 92, and that will give us 143. So it means that the neutrons number is 143. So you see the protons number is 92, and then the neutrons number is 143. So which of the option here is correct? So you can see clearly the answer is option D. So D is the answer. So we have D as the answer to this question. So ladies and gentlemen, don't forget on how to do this calculation, how to calculate the protons number, the neutrons number, and electrons number when you are given the mass number and the atomic number of an element. So let's look at another question. 1 dash 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 is a collection of 6.022 times 10 raised to the power of 23. Here is the power 23 atom slash molecules or ions. A gram, kilogram, B gram, C mole, and D centimeter. So according to Avogadro's law, 1 mole of any substance, 1 mole of any substance contain an Avogadro's number. So it means that 1 mole of any substance contain Avogadro's number, which is 6.022 times 10 raised to the power of 23. So it can be, when you said any substance, it can be in a form of atom, it can be in a form of molecules or ions. So the answer to this question is mole. So it's 1 mole. Is 1 mole. So 1 mole of any substance contain Avogadro's number. So and if it is 2 mole, so we have to multiply, we have to cross, let's say 2 moles of any substance. So when you are given mole, you may be asked to calculate the number of particles. So you may actually make this to be x. So 1 mole contains 6.022 times 10 to the power of 3. So if it is 2 moles, then in x, then you cross multiply, and then you make x subject of the formula. So this is how to do this kind of calculation of calculating moles. And don't forget, ladies and gentlemen, I have video on mole concept, and I actually solve a lot of problems that are associated with this. And if you want to watch that video, then of course you will have it in my YouTube channel and you can watch it. So then you see, so the answer here is option C. So let's now move to another question here, question 21. In the following equation for radioactive decay, what are the values of A and Z respectively? So we're given an element here, lanthanum, this which is Le, with a mass number of 143 and atomic number of 57. And of course, it produces, or it actually breaks down. This is nuclear fission, nuclear fusion, where a large molecules break down to produce smaller one. So you have 143, and then 146, and then for X is A, which is unknown, and for helium the mass is 4 and atomic number is 2, and then for the lanthanum the atomic number is 57, and then the atomic number of X is unknown. So how are we going to calculate this? Is simple. So we are going to start with the mass number. So the mass number is 146 is equal to A plus 4. You see, we have this A, then plus 4. Then we are now going to say 146 is equal to, we can actually make the A, even from here, the subject of the formula. So we can make the A subject of the formula here. So how do you do it? Then we now take 4 to the other side. So we are now going to say minus 4 is equal to A. So it means that 146 minus 4, we have 142. So A is 142. Then for Z, then we're now going to take atomic number. So it's equal to 157 is equal to Z plus 2. So we're now going to make Z subject of the formula. So we have 57 minus 2 is equal to Z. So 57 minus 2, we have 55. So this is our Z. So it means that the Z is 55. So therefore, it means that the X has a mass of 142 and then atomic number of 55. So it means that our our Z is 55, then our A is 142. So the answer to this question is option respectively, what are the values of A and Z respectively? So A, because of the what respectively, is going to be 142, and then Z is 55. So you see, ladies and gentlemen, you have to be very careful when you are actually reading questions. You see here is the word respectively make me to that make me to choose option A. If the word here, if you are not actually careful with this word respectively, you may choose the wrong option like as I did. So the answer is option E. You see, I did the calculation and everything. So because of the language, it makes me to choose the wrong option. So then question 22. The process in which a heavier nuclei divides to form a smaller nuclei of intermediate mass is known as A. Nuclear fusion, B. Nuclear fission, C. Nuclear reactor, D. Nuclear energy. So ladies and gentlemen, we have two basic types of nuclear reaction. Number one, we have nuclear fusion. So nuclear fusion is when you have smaller atom, like plus A plus B, smaller atoms combine to produce larger one. So when smaller atoms combine to form a larger one, that is called nuclear fusion. Fusion means combination. And then the nuclear fission is when you have a heavier atom, then break down or divide to produce smaller one. That is what we call nuclear fusion. So you see from the question here, nuclear fusion, it means heavy nucleus divide to produce smaller nuclei of intermediate mass is known as, the answer is nuclear fusion, because it is a heavier nuclei that divides to produce a smaller nuclei. So the answer is option B. So then we are now moving to question 23. Which of the following is used as a fuel in a nuclear reactor? So in a nuclear reactor, when you say nuclear reactor, it's a system where usually nuclear reaction takes place. So the fuel used in that nuclear reaction is uranium. So the answer is uranium, which is option B. So then we are now moving to question 24. Calculate the de Broglie's wavelength of an electron traveling with a speed of 2.65 times 10 raised to the power of 6 meters per second, given that the mass of electron is 9.11 times 10 raised to the power of 31. The Planck's constant is equal to 6.626 times 10 raised to the power of minus 34 kilogram meter square per second. So we are now to calculate the de Broglie wavelength. So the formula for calculating the Broglie wavelength is the wavelength is equal to h all over mv. The m here stands for mass, v for velocity, h Planck constant, and then the lambda is called the Broglie wavelength. So therefore, we are now just going to substitute. So the Planck constant is 6.262 divided by the mass of the electron, which is okay, here is times 10 raised to the power of minus 34. So we have this, then we now divide it by 6 points. We now divide it with we are now going to divide it with 9, which is the mass of electron, 9.11 times 10 raised to the power of minus 31, then times the velocity, and the velocity is 2.65 times 10 raised to the power of 6. So when you now take your calculator and you press this, we're now going to get this as the answer. Because it is wavelength, so it's going to be in meter. So this is the formula for calculating the Broglie wavelength. And of course, you know that, ladies and gentlemen, there are a lot of formulas that relate to this Planck constant. And it's simple, and it's even from there that all these are right. You know that we have energy of the electron. So from the energy of the electron, we can have lambda. So you can have h. H is, of course, the Planck constant, and F is the frequency. So you can use this to play around and actually drive a lot of formula. So this is what you call the Broglie wavelength equation. And of course, this is how you make such calculation. Then the next question is 25. Which of the following element or ion is isoelectric with 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So if you now sum all the index number 2 plus 2, 4 plus 6, 10 plus 2 is going to give us 12 plus 6 is going to give us 18, then plus 1 is equal to 19. So which one is actually tally with this? So which one among all these that have 19 electron? So you see this is fluorine. Fluorine has of course 9 electron. Chlorine here is minus, so it means that it has 18 electron. Neon here is having 10, and then calcium is having 20, and 1 electron is lost. That is why it is this calcium plus. So it means that it is left with 19 electron. So by counting this, we have 19. So the isoelectric element or ions that is similar with this is calcium. So the answer is option D. So then question 26, the electronic configuration of element X and Y are X1, S2, 2S2, 2P6, 3S2, then 2, 3P4. And then we have Y with 1S2, 2S2, 2P6, 3S2, then 3P5. So the bond in the compound formed by X and Y is expected to be, so you see X here, when you add all the index number there, which is going to give us 10, 12, 16, so it's 16. And then we have Y also. Then, okay, we have 10, 12. Then we have 17. So it means that Y is 17. So if you look at all these, they are non-metal. So the types of bonds that usually occur between non-metals to form a molecules or to form a compound is covalent bonding. So because they are non-metals, so usually they don't easily give electrons. Rather, they share electrons. So X and Y, in this case, they are non-metal and they are going to share electrons to form a molecule. So the answer to this question is covalent bond. So the answer is B. Then question 27, the shape of CO2, H2O, and CH4 respectively are A, bent, linear, and tetrahedral, B, bent, tetrahedral, and linear, C, linear, bent, and tetrahedral, then C, tetrahedral, linear, and bent. So ladies and gentlemen, there is a video that I made on the shape of the molecules where I have talked about how these molecules looks like. And of course, the shape of these molecules depend on the number of lone pair of electrons and the bonding pair of electrons. And of course, also the number of atoms that attach to it directly. So carbon is an element that doesn't have any lone pair of electrons, and then the number of atoms that attach to it is just 2, oxygen. So you see oxygen, oxygen, so 2 oxygen atoms. So even from here, you can see that it is linear in shape. It is linear in shape. And then we have H2O. So the central atom here, H2O, is oxygen, and oxygen has 2 lone pair of electrons. And generally, the number of lone pair of electrons, according to valence shell electron repulsion theory, it affects the shape of the molecule. So that is why of course, the water molecules here has bent shape. And then for the CH4, it is of course carbon, no lone pair of electrons, and 4 atoms attached to it. It is tetrahedral in shape. Please, ladies and gentlemen, if you want to watch my video on the shape of molecules, it is very clear, it is very crystal clear and understandable. So you can actually go to my YouTube and watch how this shape of the molecules are formed and how the lone pair of electrons affect their shape and their bond angles. So the answer to this, as you can see, is C. So CO2 is linear, H2O water molecule is bent, and then the tetrahedral is for CH4. So ladies and gentlemen, this is where I'm going to stop. Please follow me and join the YouTube channel. More of this video are going to be actually added. So see you next time. Thank you very much.